Hello, participants. Um, Thanks so much for your time. And now we want to quickly consider illustration of um, autoregressive integrated moving average using our studio. Um, uh, let me clear the console here. Fine. The starting point is to set a working directory. We are familiar with the procedure. So session set working directory, choose directory here. See, still using my time series analysis training folder on my desktop. Open. I need the following four packages: tidyverse to manipulate the data set, table one for descriptive statistics, forecast to make a forecast, gridExtra to arrange our plots in a table. Run. That's fine. So let's import the data sets. Let me see that. All right. It's retrieving the data set. All right. So let's import it. So here we have the data sets. Um, you may want to look at it clearly in the data editor. To do that, you say fix, then the objects in the brackets, run it. So this is it. So here we have date, item, production area, yield, and we have maize, rice, sorghum, then wheat. I think wheat starts in 1970, so that's wheat. And then we have production area and yield. Then for maize, rice, sorghum, the data runs from 1961 up to 2018. But for wheat, I think it runs from 1970 to 2018. So for the descriptive statistics, we have table one. We have area production yield for different items. So that's what this is telling us here. So you run it. Fine. So here we are. So what you just need to do is you show this in a new window. So if you click on it to show in a new window, so you have it in a new window. Yeah. So this is it here. So you copy. If you copy it, then you come to Microsoft Word. You paste it. No, didn't paste very well. Let me do it again. Yeah. Copy. Yeah, that's fine. So these are supposed to be, you have maize, rice, sorghum, all these things. So then you can click on this here to redesign your table, you can get table format here. Then you can make whatever change you desire and use any table format of your choice. That's clear. So let's close this. Don't save. Okay, I think I'm through with you here. Yeah. Okay, now before we can forecast, we have to convert our data to time series. To do that, we have, let's do that for maize production. I call it P maize. To convert, we use TS. That's for our maize here. After the descriptive study, I used maize in order to filter maize from the data set. Rice to filter rice, sorghum to, so that is what I've tried to do here. So, all right, good. So here I have my P maize, that is my maize, the production, because this maize contains the production, the area, and the yield. Because what I just try to do is to filter all information belonging to maize from these objects. So I do that for maize, for rice, for sorghum, for wheat. So fine, run, good. So to plot your graph, super simple. So my plot one is to plot this maize production. I labeled my Y metric tons, then I put title there. Run. Let's do that for rice. Do that for sorghum, and do that for wheat. Fine. So now that I have my plot 1 to 4, I can arrange everything in one table, plot 1, 2, 3, 4. Define number of row, number of column. So let's run through that. Run. So good. Yeah, so it's doing it. Yeah, I think it's already done. So this is the graph of maize, rice, sorghum production. You can zoom to see everything clearly. Yeah, that's fine. Okay, so you can export. You want to export it to Word document, just click here, copy to clipboard, then you paste it in Microsoft Word. As simple as that. So now that we have our plots, then we can make the forecasts to forecast for maybe the next 4 years, for instance. Or we're already familiar with how to make forecasts with naive and mean. So our main interest is this, the use of auto.arima. This is to automatically generate our PDQ, for our AR, for differencing and the moving average. Um, so let's run it up to this level here. Good. So let's get our model. So basically, you can see that our model is moving average up to 2 year lag. And it's good to check the residuals um, so that we know to test for autocorrelation and normality. So to do that one, just type check residuals. Very straightforward to do. Just run. So it's going to give us series of graphs, and you already have your region box test for autocorrelation. So you can see now this our Riemann is 0, 1, 2, so no AR. So we have to difference once uh, before before um, the variable becomes stationary. Then our MA is 2, just as we have discovered in the equation. So you can see the residual is about normal distribution, so there's no problem of um, So our normality assumption is not violated. So this ACF, this is what we are talking about, and this is clearly showing you that it is MA. Um, all right, so we have the Legion box text here, test here. So the moment you are okay with these diagnostics, then you can plot your forecasts. Um, or anyway, you can actually look at the forecast itself. This forecast, the forecast for next 4 years. That's why I say H is equal to 4. Run. So the actual forecast, this is the forecast 2019 to 2022 forecast. And you can do that also for the other methods. So I just obtained that of F3. You can do that for F1, F2. Um, then you can plot all the forecast in just one graph. So this I say auto plot maze. I say auto layer, that is add knife method, add me method, add you can add as many methods as possible. So if you have done that one correctly, now it runs very straightforward to do. Also, this is it. So we have the arima, the mean, the knife. So, but which one is the best? Which one should you actually focus your attention on? Yeah, my attention, I may not be interested in all the three. Before I can choose, I need to perform some tests. So I need the accuracy test. So perform the accuracy for F1, F2, and F3, which that is our forecast models. So run. So now, usually I normally focus my attention on root mean square error, but you can use any other method of interest. You have to select the one with the lowest. So if you check your F3, this is 26,689. You move up to excuse me, to F2, this is 32,000 plus. That's higher. So then you check for F1, that is higher too. So which means that my Arima performed better than the other methods. That's fantastic. So I'm going to focus on the Arima model forecasts. That's what I'm going to do. So I will just focus on this. So this is what I will base all my recommendation on. Yeah. So that is just it. So I want you to repeat this for the year, for the area, for say that variable, and see that data set. Then I sent one data set on cola nuts to everyone. So you can repeat it with cola also. And maybe you should try that one before you move to your main assignment. Um, Thank you very much. So